So in this lecture, we shall discuss some more advanced level problems on vectors. To remind you once again, we have decided to further classify the problems depending on their difficulty level. If you see a symbol like this ahead of the question, difficulty level is 1. If there are 2 dots, difficulty level 2. And if there are 3 dots, difficulty level 3. Higher the number, higher is the presumed difficulty level of a problem. So let's go for the first problem in this lecture. So here is the first problem. It's of the easier type, hence I am using a single dot in front of it. Problem number 1 is telling us find the component of the force. This is a force vector 5.0i, I might use a cap here, minus 4.0j plus 7.0k Newton along the direction of a vector s, a displacement vector s, whose initial and terminal points are 1, minus 3, 2 meters and 5, 1, minus 4 meter respectively. So as we start the problem, let us first quickly remind ourselves how to get the component of a vector along the direction of another vector by using the definition of scalar product of 2 vectors. For instance, let us consider this is a displacement vector shown in red arrow, and here is a force vector shown in green arrow, and I make their tails coincide at the point, say, O. So the vector arrow OA represents the force vector, and the vector arrow OB represents the displacement vector. And you are supposed to find out the component of the force vector in the direction of the displacement vector S. First of all, we drop a perpendicular from the point A on the line of action of S vector and call the foot of the perpendicular to be the point C, say. This angle is of course 90 degree. And then this length OC, this line segment's length represents the component of the force vector in the direction of the displacement vector. So referring to the triangle OAC, we can see that this is a right angle triangle, and if the angle between the force vector and the displacement vector is taken to be phi, in such case cos phi is given by base, that is OC, by hypotenuse, that is OA. And therefore OC, which is the component of force vector along the displacement vector, this is coming out to be OA into cos phi. But then OA represents the magnitude of the force vector, therefore this is coming out to be F into cos phi, isn't it? So you have got here that the component of force vector in the direction of displacement vector is given by the magnitude of the force vector multiplied by the cosine of the angle between the force vector and the displacement vector. Now from the definition of scalar product, we know that F dot S, this is given by the magnitude of the force vector into magnitude of displacement vector into cosine of the angle between the 2 vectors. And therefore we are getting that the component of force vector OC along S vector, this is already found to be F into cos phi, and this is coming out to be the dot product of F and S vectors divided by the magnitude of displacement vector S. This is F vector dot S by S. When you divide a vector by its magnitude, you get an unit vector in the direction of the vector. Therefore, this is coming out to be the force vector dot S cap, where S cap is standing for unit vector of the displacement vector S. So this is the result we are looking for. Once we are here, let us now see what they have given this force and the displacement vectors to be. According to the question, as you can see, the force vector is given to be 5.0i minus 4.0j plus 7.0 k Newton. They did not give the displacement vector S directly. They have said that for the displacement vector, the initial and terminal points are coordinates given. Initial point means for this vector here in my figure, this is the point O. Its coordinates are 1, minus 3, 2 meters. And the terminal point, that is the head, coordinates are 5, 1, minus 4 meters. And therefore, recalling the definition, how to get it, the formula S can be found to be by subtracting the coordinates as shown, 5 minus 1 into I cap plus 1 minus 3 into j cap plus minus 4 minus 2 into k cap. This whole thing you keep inside a bracket and write the unit carefully, that is meter, and it's coming out to be 4i plus 4j minus 6k meter. Once we got the displacement vector as it is, the unit vector of displacement vector, that is S cap, is found by the vector S by its magnitude, which is 4i cap plus 4j cap minus 6k cap meter in the numerator, and the magnitude of displacement vector is square root of 4 square plus 4 square plus minus 6 whole square, that is also coming out to be 6 square only. This is meters. The unit meter cancelling out, unit vector S cap is coming out to be, this is, you can check it, 4i cap plus 4j cap minus 6k cap divided by, this is square root of 16 plus 16 plus 36, that is square root of 68, and this is of course 2 into root over of 17. And if I divide by 2 up and down, I can express my result as 2i plus 2j minus 3k divided by square root of 17. Note that unit vector of S, or for that matter any vector, is a dimensionless, unitless quantity, 2i plus 2j minus 3k by root over 17 in this case. So once we have got both the force vector and the unit vector in the direction of displacement vector S cap, we can return to equation number 1 and write down that the component of force vector in the direction of displacement vector OC, that is given by force vector dot S cap, putting the values now, 5.0i minus 4.0j plus 7.0k. This is the force vector. I will be writing the units Newton later, and then dot S cap, that was 2i plus 2j minus 3k divided by square root of 17. This is the whole thing, and I write the unit, that is Newton outside. Go for this multiplication. We are aware that in scalar product only I dot I, j dot j, k dot k, each of them is equal to 1, while the dot product of dissimilar unit vectors become 0. Therefore, it's 5 into 2. I'm writing it 5.0 into 2 minus 4.0 into 2 minus 7.0 into 3. The scalar quantity divided by square root of 17 Newton. Complete the calculation and show that this is coming out to be minus 4.6 Newton in two significant figures in accordance with the accuracy of the given data of the problem. So we have got here that the component of the force vector along the displacement vector is minus 4.6 Newton. The negative value here implying that the angle phi between the force and displacement vectors is an obtuse angle, and therefore the component vector of force.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.